Hey there, in this video, we are going to go ahead and talk about linear equations, and we will talk about two different forms of linear equations and how we can show when a solution is a value is a solution to those equations. So let's jump in first with our first form. So we have linear equations are equations in which the highest power of the variable is 1. So that means it is a first degree. The highest exponent on any of the variables is a 1. The general form of a linear equation is ax plus b equals 0, where a and b are constants or coefficients, depending. A is a coefficient, b is a constant, and x is the variable. Again, a is the coefficient of that unknown variable x. Now, examples of linear equations in that form. So just to give you a couple examples, negative 4x minus 8 equals 0 would be one example. 7x plus 4/5 equals 0 would be another example, and negative 9x plus 12 equals 0 is another example. So these are just some examples of equations in that same form. Next, we have slope-intercept form. So slope-intercept form is y equals mx plus b, and linear equations can be written in slope-intercept form, which is most commonly used for graphing a line when m represents our slope and b represents our y-intercept, which we'll get into in a little bit more detail in the future. But again, the key thing here is that y equals mx plus b has m as a constant in front of the x, or in other words, a coefficient, and then b is a constant on its own. All right, and then the x and y are variables. So some examples in that form, we have, let's say, y equals 1/2 x plus 4. That would be one example of an equation in slope-intercept form. Y equals 3x minus 2 is another example. And y equals negative x plus 7. These are all examples of equations in slope-intercept form. Like I mentioned, these can be extremely beneficial when we get to graphing a line. These can be used to determine our slope, which is going to be the constant or the coefficient with the x, and then our constant that's on its own, so 4, 7, negative 2, those are all going to tell you your y-intercept of the graph. So we'll get into that a little bit more, but this is just the general form, slope-intercept form. Now let's go ahead and take a look at determining if something is a solution to an equation, or in other words, showing, depending on how it's worded, showing that a value is a solution to the equation. So any expression can be manipulated and or simplified to fit one of these aforementioned forms if it is a linear equation. So a linear equation can be written in both of these formats. So for the form ax plus b equals 0, a solution is a value that when it's substituted in for x makes the value true. So this is really just like what we did in our last video where we talked about how to determine if a value for x is a solution to the equation. So we would just take whatever that x value is and we would plug it into the spot for x in that equation. So for example, show that x equals 4 is a solution to the equation 7x minus 8 equals 20. If I look at 7x minus 8 equals 20, and I want to know if 4 is a solution, then I do 7 times 4 minus 8 equals 20. 7 times 4 is 28 minus 8 equals 20. 28 minus 8 is 20. And we see that 20 equals 20 is a true statement. So that shows us that x equals 4 is in fact a solution to that equation. So just like we did previously, we just plug that number in for x to show that it is in fact a solution to the equation. Now with slope-intercept form, we see two variables here. We see an x and a y. So if I look at the equation, for example, y equals 3x plus 12, to show that, for example, x equals negative 4 is a solution to that equation, we have to go one step further. So when we are looking at y equals mx plus b, in other words, slope-intercept form, the solution is going to be the value of x that makes the equation true when y is equal to 0. So we are always going to put 0 in for y, and then plug negative 4 in for x whenever we are trying to figure out if this is a solution. So we put 0 in for y, and then 3 times x, so 3 times negative 4 plus 12. 3 times negative 4 is negative 12 plus 12, and we're trying to see if that's equal to 0. So 0 equals negative 12 plus 12 is 0, and that is a true statement. So that tells us that x equals negative 4 is in fact a solution to the equation y equals 3x plus 12. So in summary, if we have a polynomial or an equation that has a degree of 1, meaning the highest exponent on any variable is a 1, for example, just an x, no x squared, no x cubed, nothing higher than just an x, then it is a linear function or a linear equation. Then we have general form and we have slope-intercept form. So these are really pretty much the same thing. It's just slightly different in how you look at it. So ax plus b equals 0, where a and b are actually numbers and x is a variable and then 0 is 0. With slope-intercept form, remember we have y equals mx plus b. This is typically used for graphing, and it tells us our slope and our y-intercept, and it helps us graph a line. So these are really very similar because when we're trying to figure out if a solution is or if a number is a solution to a linear equation, if we're in this first form, we just plug it in and we see if it's a true statement. And if it is a true statement, then we say, yep, it is a solution. If it's not true, then we say it's not. Now, with the y equals mx plus b, remember we put 0 in for y, and then we do mx plus b. So really it's the same concept. It's just we have to remember to put 0 in for y if we are being asked, is this a solution to this equation when there's an x and a y variable? So here, when we have that linear equation, we put 0 in, and then again, that's when we do the same thing. We plug in for x, and we figure out if it's true, and that tells us if it is or is not a solution to that linear equation.